All right, hello ladies and gentlemen, welcome to our lesson today. Today we're going to be talking about some function composition. So in the last couple of videos we've talked about all of our different function operations that we can do. We've talked about function addition, function subtraction, function multiplication, and function division. All of those together make all of our function operations. Function composition is kind of like a function operation, but we use all the function operations in function composition, but it's a little different, and you guys will kind of come to see that as we do it. So the first thing I wanted to do was kind of just give a little definition of composition for those of you that might not know. So I don't know if you guys know much about classical music, but so they would have these people who would compose these classical pieces, and compose just meant like put together. So they would take all these musical notes, right? They would take all these musical instruments and they would compose this wonderful symphony, this wonderful, whatever it was. So composing is like bringing it together. If you hear the saying that someone is really composed, that means that they have all of their like, they've got it all together. They've like got it figured out. They're not, stressed or whatever. And then, yeah, so those are a couple examples of like compositions. And so when we're talking about function composition, we're just gonna bring two functions together. So for my first example, I have, let's see, we're gonna have f of x equal to x, and then we're gonna have g of x equal to 3x minus 2. Okay, so function composition. It's gonna look like this, which is a little gross, okay? So let me talk about this first. So we've done problems, we've evaluated functions, right? So f of x is equal to x, and we've evaluated functions. So if I asked you guys to solve f of 2, you would know that this means we're going to plug in a 2 for all of our x's in f of x, because that's how we've done it, right? And we have this 2 here that we've put in for our x, so we're going to take a 2 and put it in for that x as well, right? So then our f of 2 would just be 2. Similarly, if we had f of 4, we've plugged in a 4 for this x, we're going to plug in a 4 for that x. So it would just be 4, right? Okay, so you guys get that. So now what we've done, we've plugged in a g of x for our x here. So our f of x is now turned into f of g of x, which means that for every x in f of x, okay, and there's only one here, that's why we started here. It's a simple, well, not simple, but a simpler example, okay? For every x that's in our f of x, we're going to plug in g of x. And so what is g of x equal to? Well, it's equal to 3x minus 2. So f of g of x is going to be equal to, we're plugging in a 3x minus 2 for every x, and there's only one x. So it's going to look like this. And maybe this is a bad example just because f of g of x is not always going to be equal to g of x, I promise. This was just this example so that you guys could kind of see. So again, really fast. We took our g of x and we're plugging it in for both of our x's, or for all of our x's in our function of x. And so the way that you read this, so in our first function video I talked about how we called functions, or we denoted functions like f of x, and then I went into depth about how f stands for function, and that's why we use it most often. And then x is just our independent variable, which we also use most often, but it doesn't have to be x. So the way that we say this is f of g of x. And so this is just saying that our function of f, okay, and then our independent variable, or our input, is g of x, okay? And so g of x is right here, and that's kind of how I would explain that, right? And so another way that you'll see this, you'll either be asked to calculate f of g of x, or you'll be asked to calculate fog. And this little symbol, it looks like an O, but it's actually a special composition symbol. Okay, so this means that we're composing our functions f and g, and we're bringing them together. And so this, f of g of x, with all the parentheses here that's kind of gross, is the same as f of g, okay? And so what we can do, we can also do we can do g of f of x. So similar to f of g of x, we took our g of x and plugged it in for all of our x's here. We're going to do the same thing, only now we're going to look at g of x as our main function that we're looking at, and we're plugging in an f of x for every x here. okay? So we're gonna take our f of x, which is just x, and we're gonna plug it in for every x here. Now, this composition happens to be the same no matter what way you do it, and that will happen when one of your functions is just x. It'll happen this way, but it will not always happen that way, and we'll do some examples. So this is g of f of x, and the other way that you'll see this is often called goff, okay? So this is just saying that we're composing our function g and f together, and g is like our main one that we're looking at, or it would be the first one in the parentheses. So personally, I don't really like fog and goff, personally, okay? So, but I know what they mean, so that when I see them, I can write them like this. Okay, so fog is f of g of x, and you could kind of see that actually when I wrote it out, when I had f of g of x. You can see how they get fog, right? And that little composition symbol looks like an O too, which helps. So fog and goff, okay? So the first letter in our little term there, fog, goff, is the first function that we're looking at, and then the second letter, the g or the f, is what we're plugging in. Hopefully that makes some sort of sense. Okay, so now we're gonna do an example where our f of g of x is not always equal, and where our f of g of x and our g of f of x are not always equal, because that's not always the case. So we're gonna have 2x plus 1, and then we'll have x squared minus 4 here. All right, so now, if you were asked to find f of g of x, which is the same thing as fog, okay? If you were asked to find these, we're gonna take our g of x and plug it in for every x that exists in f of x. So what that's gonna look like, okay, so our f of x says we have 2x plus 1. So we're gonna have 2 g of x, okay? We'll do it like this first. 2 g of x plus 1, okay? And so now, if we have it written this way, we're just gonna look and see what g of x is equal to and plug it in there. So we'll have 2 times x squared minus 4 plus 1. And then to simplify this, we just need to shoot some arrows, okay? 2x squared minus 8 plus 1, and then we combine these like terms here. We have 2x squared minus 7. Okay, so the way that I would start by doing this, if it helps you guys, I would start by writing it with the g of x in here instead of writing it with the whole thing. So if you want to do that one intermediate step, I would definitely suggest that you do. If you don't want to, totally fine, okay? You can skip that step if you can do it in your head. I've been doing this enough that I can skip that step, but I wanted to show you guys so that you can utilize it if you'd like. Okay, so now, if we were asked to find g of f of x, and I shouldn't write it like that. So g of f, which is equal to g of, wow, struggling. Okay, so goff, g of f of x, okay? So the way that I would do this, I'll show you guys the intermediate step again. Okay, so now our main function that we're looking at is g of x, and we're gonna plug in an f of x for every x in g of x. So what that's gonna look like is gonna be f of x squared minus 4, okay? So what this is gonna look like when we plug in, or I guess I'll just do the little erase. I can kind of cheat when I'm on the whiteboard. Okay, so we have f of x in here, and our f of x is just 2x plus 1, all right? And so then we would FOIL this out and we would come to our answer. I think I have a little bit of room here at the bottom. I'll try and do it real fast. It'll probably be, let's see, 4x squared plus 4x plus 1, maybe? I hope that's right. You guys can double check that FOIL for me if you'd like. Okay, and then that minus 4 is just hanging out. And then so our final answer would be, or our final simplification would be 4x squared plus 4x minus 3. All right, and yeah, double check me on that, let me know. Sweet, so we have our g of f of x now. This one was a little harder because we had the x squared, but you can see that it's the same process. And so, so hopefully that's kind of starting to make some sense now. So now I want to do an example that's slightly different, but largely the same. Okay, so sometimes you'll be asked to find f of g of 2. And really I kind of goofed. I shouldn't have erased all that work. But so f of g of 2, what we're doing now, If you'd like, there's a couple ways that you can do this. Similar to our other function operations, you can find this general formula, okay, like this, f of g, well, you could find f of g of x and then plug in a 2, or you could find g of 2, which so we just found the general form a second ago and I just erased it, so I'm not gonna do that one because we just did it. So all I would have had to have done is plug a 2 into our equation that we had. So what I'm gonna do is show you guys the other way, which is find what g of 2 is first. So g of 2 is equal to 2 squared minus 4. Okay, so g of 2 is equal to 0, which is, okay, 2 squared, 4 minus 4, 0. So now you can take that 0 and you can just plug it into f. So now we're going to find f of 0 because, okay, so follow me on these steps. We were doing f of g of 2, which meant that we were going to plug in a g of 2 for every x that was in f of x. So the one way we could do that was plug in this whole thing, okay? And by plugging in this whole thing, we'd end up with the general formula, which I just erased and I messed up, I'm sorry. Or what we can do is we can find what g of 2 is equal to, which is 0, and now we're just plugging that into f, because where we were going to replace g of 2 with all the x's, we found out that g of 2 is equal to 0, so now we're going to replace 0 for all of our x's. So f of 0 is 2 times 0 plus 1. As we know, 0 times anything is 0, and then we have plus 1 there. So f of g of 2 would be equal to 1. Okay, so if you can find the general formula, if you can do f of g of x, then finding f of g of whatever number shouldn't be too crazy difficult because you're just going to plug that number into your formula. Okay, so now let's do one with g of f of something. We'll find out as we go. So let's do g of f of 8's my favorite number. We'll see if it isn't too crazy here. Okay, so again, we could do this by doing the general formula first. We could find g of f of x first, which was that kind of gross binomial we had down here that I erased. Or we could find f of 8 first, and then plug that, whatever we get for f of 8, into g of x. So I'm going to do it right over here. F of 8 is equal to 2 times 8. That's a really skinny 8, but it is one, I promise. Okay, is equal to 16 plus 1. It's equal to 17. And yeah, this number's, okay. So we'll see if I can do 17 times 17 in my head. I might have to cheat and do it on the board, that's fine. Okay, so now we know that f of 8 is equal to 17. We were going to plug f of 8 into each of our x's here, which there's only one. So we were going to plug all of this into this x, but now that we know what f of 8 is, we can just plug in g of 17, which we know that these are the same because f of 8 is equal to 17, so g of f of 8 is equal to g of 17. Hopefully that makes sense. If you guys need some more explanations, ask me. I actually kind of intentionally tell you guys to ask me stuff to see if you're watching, and if anyone comes and asks me, I know you're watching, which is awesome. No one's come and asked me yet, so I kind of feel like I'm doing these YouTube videos for nothing, but that's okay. It's good practice for me. So anyway, just watch the videos. Okay, here we go. Okay, g of 17 is equal to, that means we're plugging in a 17 for every x here, which there's just one. Okay, and now I'm going to try and do some mental math. Okay, so 17. Okay, I'm going to cheat. I'm just going to cheat. So, or actually, I'll show you guys how I would do it in my head, actually. So, okay, we're getting a little off track, but the way that I would do 17 and times 17 in my head is 17 times 10 plus 17 times 7, okay? So 17 times 10 is 170. 17 times 7 is 119. Okay, so then 289. Sweet. Okay, so 289 equal to 289 minus 4. And then 289 minus 4 is 285. So turns out that using my favorite number there was kind of gross, so didn't think that through. But there you go. We can plug in any number that we want once we know the general formula, or even if we don't know the general formula, we can just plug in an 8 into our, well, not always an 8, but we can plug in our number into our function and then plug whatever we get from that into our bigger function, or our first function that we're looking at. So just a reminder, this would be asking you to find g of f, keep writing it like of, I can't help it, g of f, and then it would say like at 8 or something, at x equals 8. So a couple different ways you can see it, but it's all asking you to do the same thing. Yeah. There you go. So that is function composition. Quick reminder, so composition is just like bringing two things together, and function composition is no different. We have two functions, and when we do f of g of something or g of f of something, we're just bringing those two functions together and making them one. So just like I was talking about those classical music creators, don't know the right word for that, can't think of it right now. Just like they would compose and bring all of those musical notes and instruments together to make a beautiful symphony, we're making a beautiful math symphony with functions. You guys might not think it's beautiful, but that's okay. So yeah, composition is just bringing things together, function composition, bringing functions together. We did a few examples. I'm not sure what's coming next for as far as videos and lessons goes, but I guess you guys just hang out and we'll find out together. Sweet, so have a wonderful night. I will see you guys tomorrow in class, and yeah, bye.